So one of the things that we've added into the 2018 models that is a very useful feature is the ability to do a lot more diagnostic um, features. And so we have just on our home page here, you'll notice in the top right corner, right between the time and the exterior temperature, a red flashing triangle with an exclamation mark. So this is telling us that there's some sort of error or fault. So simply just pressing on that will take us to the faults page, and in plain English we spell out exactly what's going on. Now this won't tell you if you don't have enough air in the tires or if your fuel's going to run out. This is specific to the Spyder system. But in this case here, we've created a false scenario by just unplugging one of the keypads, in this case the passenger console. And you can see here that it's telling you that the passenger console switch panel is offline. So we can't tell you whether the green wire is broken or there's a connector that's come unplugged or whatever, but it definitely points you in the right direction of where to go. So just simply hitting that little button will take you right there. In addition to that, you can just click on the little tech support button and it will actually take you to a 3D barcode that you can scan with your phone, which will direct you right to our website, or we also list our website there with the username and password that you can use to watch helpful videos like this, as well as look at schematics and other troubleshooting resources. So we're going to show you now how to access a number of other diagnostic troubleshooting features that are built right into the Spyder control system here for 2018 Phtn and bus models. So simply go to the settings page here, and within that page you'll notice there's a diagnostics button, and in there you have a list of a bunch of different diagnostic features you have. So in this particular tab we're looking at the module status. So here we have listed all the different modules, control panels, and touchscreens that you have within this particular Phtn model. And so here you can see all the different modules listed with their net LED status shown right here for you, so that you don't have to go looking at every net LED on each control panel or each product. And as well, you have listed here the firmware and configuration revisions that may be useful and something that you may be asked to provide or confirm if we're doing some troubleshooting on the phone with you. In addition to the control panels that you're used to seeing, we've added as well for 2018 the air conditioner controls, which are now networked for 2018 models. So each of the air conditioner units are listed there, as well as the Magnum RVC bridge that allows communication with the Spyder network and allows you to see the status of that as well. So now we're over to the switch status page. Just like the module status page, you see each of the switch panels or keypads listed here. And just for the sake of demonstration, again, we've unplugged the passenger console keypad, and you'll notice here that the green LED is not lit, indicating that the keypad is not online. Again, could be due to a connector issue, a pinched cable, something that was unplugged. And as soon as it's plugged in, that green, and it comes online, that green LED would come on. So all of the net LEDs that you would typically be used to seeing on the keypad are represented here to show you whether a product's online or offline. In addition, we have the firmware and config revision status, which again may be useful if you're asked to provide that information on some troubleshooting on a phone call. Alright, so here we are on the fault status page now, and you can see the simulated failure we've created here by unplugging the passenger console switch panel. And you see the tech support thing here as well that gives you the tech support information. We plug the keypad in now, and you can see that now the fault has disappeared. And so again, you can at a glance see here anything that needs attention or a fault that needs to be addressed. So on this page we actually list all the inputs and outputs on the G6 house panel. These would simulate what you would see on the LEDs on the front of the panel and on the RSI 9 on the back of the panel. And so basically this is a representation of the LEDs on the screen here. And so you can see we have most of our lights turned on here, so this is representing the outputs for every single circuit. And as well, you can see a number of things other than lights. We have the vent fan lids shown here, so you would see whether a fan is on or off, whether the lid is up or down or in motion. You would also see something like the bed lift and the TV lift. So for the sake of simulation here, we're just going to be pressing the TV lift up and down, and you'll notice the green LEDs momentarily turning on and off for the TV lift as well. So those are all your outputs, really useful in determining if your outputs are actually triggered to turn on and off. This will not tell you whether the 12 volt output is actually outputting 12 volts. So for example, if you had a short circuit on a wire, you would not see this indicating that. It would just tell you that the channel is supposed to be on, but at this point, this LEDs that are shown here do not tell you whether the circuit is tripped or something like that. Additionally, we have inputs shown here. So in this case, we have a Phtn here that has a bed lift and a water heater. And so the water heater would be the fault. If there was a fault on the water heater, the bed lift would show you that the bed lift is completely retracted in this case. So we can see here we have no water heater fault, and we do have the bed lift retracted. We have our thermistor inputs here for our floor heat zone, represented by 1 to 5, just like you see it on the floor temperature settings. And we also show the thermistor readings for each of the zones, front, mid, and rear, for the air conditioning and heating zones. So here we have the G6 chassis and air conditioning page. And so once again, just like we had on the G6 house panel, you see all the outputs listed here. And again, this tells you whether the channel is supposed to be on or off. It will not tell you if you have a wire broken or a short circuit or anything like that at this time. So all the outputs here are represented. In the case of the chassis panel, typically most of the loads are not active unless you're running slide outs or awnings or things like that. In this case, we'll show you for demonstration's sake here the passenger fan high and low turning on and off. And so you can see there the LEDs turning on, we're on high, now low, and now off. And so you can very easily see what things should be on and off at a glance here. Additionally, you can use this as actually a load list, and I'll just jump back to the house page. You can actually see what each circuit is, which channel it should be on, and what circuits are on what product, and so very useful that way as well. Over here on the air conditioning section, you can actually see for each air conditioner whether the compressor's on, the reverse valve in the case of heat pumps, and then the fan high and low for every single one of the air conditioning zones. So just jumping back to the module status, here we see whether it's online or offline, and over here on the output page we see whether it's actually putting an output on each of the individual channels. So now we're on the G8 module status page, and here you can see listed all of the different outputs on the G8 module. Now just to clarify, the G8 module is a control module that's located in the same area as the Magnum inverter generator on the driver's side in one of the storage bays on the ceiling of the bay. And so this is a module that covers a lot of the mechanical loads like your awnings, water pump, your outputs for your furnace, your merge solenoid. So again, you'd expect to see any of these that are on be green. So let's just turn on the water pump here, and you can see the LED for the water pump turn on. Now this is the water pump output because it's on the G8 output page, and we'll cover the input here in a minute. So that's the output side of things. Now we're going to just move over to the input side of things. So these are inputs from various things like your generator, ignition switch, rocker switches for your slide outs and things like that. We're going to spend a few minutes on this just because there are a lot of implications when inputs like this are not working. So we're just going to kind of walk through them one by one. So in this case, you can see we have the generator running. This is not telling you whether the generator switch is being pressed or anything like that. It's simply telling you that the generator is running. So currently we have the generator running. We're going to shut it off here, and you'll see that the generator indicator shuts off. Next, we're going to look at the ignition, and so this is simply telling you whether the ignition is on. The LED will turn green, and so you see here we've just turned the ignition switch on and the LED turns on. We'll turn it off and the LED will go off. The park brake is currently set, and we're just going to leave it set here, but you can expect to see that when that park brake is on, the green LED will be on, and when it's turned off, the LED will go off, or the indicator light. The tri-mark is actually only applying to the Phtn models. On the bus series, there's a different method of communication between the tri-mark and the Spyder system. But for the Phtn models, there's an output from the tri-mark control module that goes to our G8 input to turn on the exterior door light just above the door. So we're just going to press the unlock button here on the key fob, and you'll see that that LED stays on for about 20 seconds. And that's to keep the door light on, and shortly after this LED turns off, the door light will shut off. Next, we're going to look at the door pin switch logic, and you'll notice that there are actually two listed here. Logic A applies to bus models because of the type of step that they use, and logic B refers to the Phtn models, which you can see here we have the door closed, so the green LED is on. When we open the door, the green LED shuts off. So what this is used for on a Phtn model is if you're coming into the motorhome, the entry light will turn on when you open the door for a period of time and then turn off if it was off. If it was on, the entry light would just stay on. If you also open the door, the keypad backlighting on the entry switch turns on, and so those are just some of the inputs features. With the door pin logic A on a bus model, it will do all the same things, plus if the entry shade over the door was down, when you open the door you would see this light up, and in addition to the things I mentioned earlier with logic B, like the road light and your backlighting on your entry keypad, the entry shade will go up when you open the door. Next we have your water pump. Now over here we touched on the water pump output. This is actually the water pump input. It's the rocker switch in the plumbing bay that's a momentary rocker switch that's used to toggle the pump on and off. So every time that that switch is depressed, you would expect to see this LED turn on. Additionally, now we're going to look at the slide out switches. So these are the inputs from the slide out rocker switches that are built into the side of the seats for the front two slides. So in order for these to work, you actually have to have the ignition switch on. So we're going to turn that on now. And now when the rocker switch for the driver's side front slide out is pressed, extend and retract, you'll see the LED light up there momentarily as long as your finger is depressed. So if these LEDs are not lighting up and you're wondering why the slides are not working when the rocker switches are pressed, it's because we're not getting a signal to the G8 module. So in that case you would look at a wiring issue or a switch issue on between those rocker switches in the seats and the G8 module inputs. All of these inputs and outputs here are referenced on our pinout diagram within our written manual that you can download off the website. And also there are schematics that outline the functionality of each of these inputs and outputs and how they play into the rest of the system. There are further inputs here for temperature. So you can see here we have the bay temperature and exterior temperatures listed here. So if you were to see something like fault error, you maybe have an issue with the thermistor or a wiring issue. So these are all listed there just for your troubleshooting purposes as well. We have voltages listed here. Of course your house and chassis voltages here. So you can see the house is charging here at 14.5. Chassis is not merged at this point because we're above the 12.7 threshold, so at 12.5. Anything below that you would see these two battery banks merge and the voltages would be very similar. The house sense, or also referred to as house disconnect sense, is what we use to determine if the house disconnect is on or off. So if the house disconnect were turned off, of course this screen would go blank, but at that point it would also shed the loads on the G6 chassis panel that should not be on, thereby making sure we don't drain the house battery by keeping loads on the chassis panel on. So that's just basically telling you whether your house disconnect is on or off. So on this page we have the shade status is shown here, and so once again this doesn't tell you whether they're online or offline, it tells you more of the outputs here. So you can see the outputs for the shades and the RSI 11 inputs for the inputs on the rocker switches on the dash that will tell you whether a rocker switch is being depressed or not. And so for this video we actually have a Phtn here, so you don't see the other G5 shade module that would be present here if this was a bus. And so currently we just have the cockpit shades shown in this model here. And on a Phtn, of course, you just have the windshield day and night shades. And so if you press the buttons to run those shades, you would expect to see the green LEDs coming on here. Of course, these just duplicate the LEDs that are built right into the module as well. And so you can very quickly see whether a shade channel is on or off, and whether the rocker switches on the dash are being registered by the RSI 11. Just to comment on the locations for both of these while we're in this video. The G5 shade module in the cockpit is located in the cabinet that's above the windshield on the passenger side. So there's a removable wooden panel that you would remove, and the G5 shade module would be located behind that panel. The RSI 11 is located in the same watertight box that the G6 chassis panel is in. It's a small little circuit board that the rocker switches are connected to, with a wiring harness going from the dash to the RSI 11 that's located in that electrical enclosure. So we're going to talk about the interface with the Magnum inverter charger. And on this section we're going to actually show you how to make the inverter charger settings and how the user interface works. So on a 2018 bus or Phtn model, you'll notice that the user interface that used to exist as a separate panel for the Magnum inverter charger has been removed, and it's been replaced by a Magnum bridge module, which is located right beside the inverter in one of the storage bays. And so the inverter charger functionality is now displayed on this screen here. So you can see here we have the inverter charger status, we have the charge rate here, and so all of the information that you would have seen previously on the Magnum inverter charger user panel is now ported over to the 7-inch screen for the 2018 models. Now I need to explain that the actual logic, the control, and the operation of the Magnum inverter charger is maintained by the bridge module. The Spyder system does not control the Magnum inverter charger. It's merely a user interface that allows you to change the settings by simply pressing on the settings button there. And in this section here you can see now each of the different readouts that you would have seen on the Magnum inverter charger panel previously, and change the different various settings that are part of that. So the bridge module produces the information that you see here that shows each of the different readings for voltage, current, frequency, both on the AC and DC side. So here we have the DC voltage and current that's being produced by the inverter charger in this case. Now you will notice the readings here may vary slightly from the readings that you see here. So in this case we're seeing the house batteries at 14.3, here it's at 14.5. There is a bit of a discrepancy because the power is being produced by the charger, and the reading for the voltage that's shown here is taken at a different location in the DC power grid. And so you'd expect to see a slight difference there. The current that you see here is the same current that you would see showing here as far as the power that's coming from the inverter charger and going into the house batteries. Going further down here you'll notice the AC voltage and frequency that's coming into the inverter charger, and in this case because we're plugged into shore power, that's passing through to the output for the inverted loads that are on the breaker panel as well. The charge rate is the only thing that the Spyder system controls on the Magnum inverter charger, and that's only when EMS is enabled. If EMS is disabled, you'll notice here that the charge rate stays the same, but now the charge rate is controlled completely by the setting that you have here. In a case where you're in EMS mode, the power that's available from your shore may be limited, in which case the EMS or energy management system may reduce the charge rate. Even though it's set to 80% here, it may be down to 10% here if you have a limited amount of shore power available. So that's the only setting that the Spyder system would adjust. Everything else is completely controlled by the bridge module, and what you see here is just simply a display of what the bridge module is showing and how it's controlling the actual inverter charger. Further down here you'll see there's a section for faults. In this case there's no faults. These faults would be readings that the Magnum inverter charger would produce. It wouldn't tell you anything about the Spyder network or anything like that. It would just simply tell you any faults that are in the inverter charger, such as over temperature or various things like that. Further down here you have information that's produced by the bridge module, simply telling you the firmware revision number, the model, and the bridge firmware as well. And those may be details that if you're speaking with a Magnum tech, they may ask you for that information. Over here we have the settings adjustments that you're able to set, and beside them we've actually listed here what is recommended for the various settings, as well as the minimum and maximum settings, just to give you an idea there. For the settings here, because these are actually functions of the Magnum inverter charger, we'd highly recommend referencing the Magnum inverter charger manual, and it will tell you a little bit more about what these settings should be and what they do. So on the Magnum inverter charger settings page, there's also one more section of settings that you access by pressing the battery settings. And this is something that should only be done with very great care and caution. We recommend highly that you consider what you're doing and verify the settings with the manual for the batteries as well as the inverter charger before you make any changes to the settings here. And so you can see here you have the amp hours for the battery bank. Once again, you'll want to consult with the manual for the batteries that you have in the motorhome and the number of them, and as well select the battery type very carefully and make sure you understand the implications of each setting. Alright, so you can see here now that we have the ability to have all of the same types of settings that you may have been used to with your previous Magnum inverter charger user interface, and we also have provided some additional functionality with the showing of your charge current and how much is going into the batteries. We also have, just for basic operation, just your on-off buttons for your inverter charger. As well, we display here the actual charge status. So whether you're in absorb charge, in this case, you can see it's in absorb mode there. There's also bulk and float modes as well, so those would be displayed there. In this case, the inverter is on, and because we're plugged into shore, we have pass-through shown here, and then just by touching the button we can turn the inverter off. Of course, pass-through will still be enabled in that case, but the inverter will not kick in if we lose shore power. It will if I turn this back on. The inverter is now enabled there. So basic on-off functions are all just available at a glance here at the touch of a button. So we're going to talk a little bit about the Energy Management System, or EMS, that you see represented here on the power page in the middle of the screen. Energy Management System is an intelligent system that manages your AC power usage when you are in cases where you have limited amount of shore power available. So in this case here, we're simulating that we only have a 15 amp service, and you can see here that you have the selection to select whether you have 15, 20, or 30 amps. So that's probably the most important setting when you're looking at your energy management system. And so once you select your power that's available, the system will calculate how much power is currently being used. So in this case, we've got 3.7 amps on line 1 and 0.4 amps on line 2. So it adds those together, in this case giving us just over 4 amps. So it says, okay, you have 15 amps available. It allows you to basically maybe be able to run your fireplace or your dishwasher or something like that. However, if you tried to turn on one of your air conditioners, the energy management system knows that there's not enough power available when an air conditioner draws on power up over 15 amps. So if I were to go to the power page and turn on my front air conditioner, you'll see here that as the front air conditioner goes to turn on, that it will actually not let the compressor cut in, because that would mean that your shore breaker would trip. You'll also notice here as we've done this that the charge rate was reduced in an attempt to see if there's enough power available for the air conditioner to turn on. Now in this mode you can see here that everything else was shed, and everything here is listed in order of priority. So on line 1, the items that are lower down are a lower priority, so they would be shed first. And on line 2, same thing. The air conditioners have the highest priority in this order. Alright, so you can see here now that we've had some time elapse, and it hasn't allowed the front air conditioner to come on with only a 15 amp service. Now I can adjust the amount of shore power available. So let's say I adjust that to 30 amps. Now you're going to notice that within a few seconds the compressor will actually be allowed to turn on, because it says now that I've got plenty of power available, only drawing about 4 amps, 4.4 amps. So you can see now that the front air conditioner turned on. There may be enough power for it to allow the second air conditioner to run if I were to turn that on, but that's about it. One of the things with the power management system, as it's connected to the climate control, is that it will actually allow you to run all 3 air conditioners. Of course the compressors can't be on, but you can have all of them enabled, and what it will do is intelligently switch between the air conditioner that has the zone furthest from the set point. So the air conditioner that is the hottest will be allowed to basically cool that area first, and then it will shut off, and the next zone that's closest or furthest from the set point will turn on, and it will just cycle through that, so that even though you maybe only have enough power to run one air conditioner, it will attempt to keep the whole coach cool, running all three ACs at different times. Alright, you'll also notice now that we're still on the 30 amp setting here. We have one air conditioner running, and so we have plenty of power still available. The charge rate initially was reduced down to 10%, so that the charger is not drawing as much AC power. But now that we're on a 30 amp service and we have room to spare, you'll notice that the charge rate is now allowed to increase, and it will go back up to the highest charge rate setting that you've set in your inverter charger setting. The EMS system is again a system that will help you manage the shore power that's available and the loads that are drawing that shore power, so that you don't trip your shore breaker. If for whatever reason though that it is determined that EMS is not desired to be controlling the AC loads, it's as simple as just pushing this button here, and now you can see that EMS is disabled. So at this point, if you were on a 20 amp service and you wanted to try running all three air conditioners, you could do so simply by just turning that off. Just turning it on again, it will take a second to enable, and you can see we're back into power management mode here, where it will ensure that your shore breaker is not tripped and that you're operating within the power that's available. So in this section, we're going to explain how the auto generator start, or AGS, system works. So the auto generator start system, or AGS, will allow you to automatically have the generator started whether your batteries are low, whether you have insufficient shore power, at different times that we'll touch on here in a minute. To turn on your auto gen feature, you simply press the AGS button. Now, because of some of the safety concerns, we have a warning here that encourages you to consider where you're enabling AGS. You don't want to have this enabled in a place where the motorhome's in a building, or in a case where it's not safe to have the generator start. So there's a disclaimer here that requires you to cycle the ignition so that the AGS doesn't inadvertently get turned on. So we're going to cycle the ignition now. And at this point you can see now that the AGS button is lit blue, and so the AGS will now turn on based on the parameters that are set up in your settings page. There are three different things that will turn off your AGS settings. One would be starting the generator manually, whether here or at the dash. So anytime that the system senses that the generator is started manually, it will disable the auto gen feature. It will also turn off if we cycle the ignition. So we're assuming that perhaps the coach is being moved, and in that case we want to have the AGS manually enabled. So we're going to just try that again here. And you'll notice that when the key was cycled again, there's a disclaimer now that pops up and informs you that the AGS has been disabled, and so that you know, the operator would know that AGS is currently not active. The other way to turn AGS off, of course, is just to press the off button when it is turned on, and the AGS will shut off. So now we're going to talk about how to change the settings or set up your auto gen start system. So to access these settings, you simply press the little settings page here, and two options are now available to you. You have the manual setup, so if you're a pro at this and you know exactly what you want to adjust or change, simply just hit that button. Now available to you are the start triggers, things that you want to have the generator start by, things that the parameters of when that would start, when they would, how long things would run, and under what conditions they would run, and when they would stop. Now, if you're needing a little more assistance with that, we kind of have an easy setup that walks you through each of the steps. So we just simply have a short question list that kind of walks you through each of the steps. So when would you like the generator to start? And when the house batteries are low and need to charge, when the climate control system needs power, or when there is shore power but it's insufficient to run the air conditioner. So we just kind of walk through that, and based on your answers, different options are available to you here. We also have the recommended settings and the minimum and maximum for each of the different start, run, stop considerations for setting up your AGS. So simply walk through that. Now let's just take a look at the actual triggers that are available. So here we have low battery, HVAC, and insufficient shore power. When I select each of those different things, or unselect them, it does change some of the things that are available here as far as options. We also have quiet time that's available, so if you're only wanting the generator to run at certain times and not run at other times, that would be just defined here as well. Here we have the starting section here. So in this case, you have the ability to change when you're charging your batteries. You would say, I want my generator to start when the batteries are at this voltage after a delay of this many seconds, and then I would retry 5 times. So we just kind of walk through when the generator will start there. Now that it's running, I'll say I want the minimum run time to be 10 minutes, and I can adjust that to whatever level I want. I want my maximum run time to be this many minutes, and then the parameters where the generator would start. So we say when the Magnum charger enters float mode or bulk mode or whichever, that's when the generator would start, and then we have a delay of after so many minutes there as well. So fairly straightforward, kind of manual setup and a really easy setup that just walk you through each of the parameters for that. So in this video we're going to do a quick walkthrough of the complete motorhome and identify the locations where each of the Spyder Controls components are installed. We're going to start off here at the entry. We have, of course, the entry keypad that is accessible just coming into the doorway. On top of the passenger console we have another keypad for the passenger to operate various functions while seated in the passenger seat. And so those are the 2 locations for keypads. We're going to move up to the cabinet here above the passenger side window, and the shade module that runs the motorized shades in this location is located just behind this control panel here. And so just removing the screws and just pulling out the wooden panel there will allow you to access the shade control module in that location. These switches in this location of the dash are actually part of the Tiffin dash, but there are a couple of rocker switches that are directly connected to the Spyder system. The solar shades for the windshield are part of the Spyder system on a bus. There'd be the tow window as well that would be part of that. And the step cover, the generator start stop are also tied into the Spyder system as well. Although they're not Spyder Controls products, they interface with the Spyder Controls control module that's located in the front electrical compartment that we'll show you in just a minute. So just moving into the living area of the motorhome now, you'll notice a keypad here in the living area. It depends on the floor plan a little bit, but you'll always have one keypad that operates a number of lights. You'll also have power shades. This is Phtn, so the living area shades are manual shades, but you'll have that keypad there. You'll also, if this was a bus, in this cabinet here that is in the slide out that has the most shades. So if you just have one shade in that slide out, that's not the one we're going to be looking for. It's the one that has 2 or more shades. There's a shade control module located behind this control panel here that operates the day-night shades in each of these windows as well. Moving into the galley area, of course, there's a switch panel here that operates the lights for the task and kitchen area, as well as some of the main living room area as well. Alright, so moving further back into the motorhome, in the mid-bath location, you may not be able to see it from there, but there's a keypad here that operates the mid-bath lights, vent fan, and then moving further back we have our 7-inch color screen, which is kind of your main control center to operate, of course, all your lights and the various functions of the motorhome. So then moving back into the bedroom area, we have user interface on either side of the bed. On one side of the bed we'll have the 4.3-inch monochrome screen that allows you to control most of the same functions that you have on the 7-inch screen in the hallway. And then on the other side of the bed you have a normal keypad for operating lights and the ceiling fan and the backlighting. And then moving into the rear bath, we have here the keypad that operates the rear bath if it's a floor plan that's equipped with that, for the lights and the vent fan in that location. Moving into the rear of the motorhome, whether it's equipped with a rear bath or it's one without a rear bath, in the back of the motorhome is where you'll find some additional components. Here we have the G6 house panel, and this is the control panel that handles all of your interior lighting for the motorhome. It also handles things like your vent fans, your ceiling fan, and various things like that. And just consult the manual and it'll actually tell you exactly what is controlled by this control panel. Inside of this electrical box here is another control module called the ACR3, and it is a device that does all of your load shedding for your high voltage loads, for things like your washer dryer, your dishwasher, fireplace, and things like that. Going further back in the control box here, you'll have two heated towel floor relay boxes that actually do the high voltage switching for your heated towel floors if the motorhome's equipped with that. And so they'll just be receptacle-like looking devices at the back of this control panel here as well. So moving to the outside of the motorhome now, we're going to go to the front electrical compartment that is located just in front of the driver's side front tire. And we have two control panels here that I'll point out. Inside this water resistant enclosure, we have the G6 chassis panel, and this control panel is primarily dedicated to operating your slide outs, your generator start stop, and some of your exterior lights are operated from this control panel. Additionally, we have some constant outputs here on breakers that are dedicated to things like powering USB ports, power seats, and things like that. Then below the G6 chassis panel, we have what we call the RSI 11 module. That's short for rocker switch interface, and that is what allows the inputs from the dash, those rocker switches that we pointed out earlier, to interface with the Spyder control system. So things like your power shades, your step cover rocker switches end up interfacing with this board, and that's how those controls get into the Spyder system. So new for 2018 is an additional location where there are some key Spyder controls components installed, and that's the location here in the same compartment as the Magnum inverter charger. So just to start off with, you'll notice the Spyder controls DC distribution panel, and this panel is just basically a battery switch and circuit protection panel. There's no intelligence in the panel. It allows you to turn on and off your battery disconnect for your house batteries, as well as your inverter charger, and then there are a number of breakers here that are listed on the load center here. Then we're going to just move on up into the inside of the bay here, and we have a number of other components here. On this black control panel here on the ceiling of the compartment, there are three main components here that I'd like to point out. This module here is what does your battery disconnect for your house batteries, and this is basically your house power. So this is different than your battery switch. This will actually just kill your house power when you turn it on and off. This is controlled by the rocker switch at the entry, and right beside it is what we call the G8 control module, and it does the control of a lot of things. It's a very central panel, and it controls things like your power awnings. It also controls your water pump, and has a number of inputs that go to it as well. Things like your rocker switches on the driver and passenger seat for your front slides all interface here. Your voltage readings are taken from this location as well. For your house and chassis batteries, your battery merge function is also controlled by this module as well. This module also houses a lot of the logic that takes place for things like your energy management system. So this module is kind of monitoring all the AC power consumption and making a lot of those intelligent decisions. Behind that we have what we call the CAN router, and this module is where all your network connections for all of the various components in the motorhome connect to. So each of the keypads home run back to this location, your touch screens, each of the control modules all end up going to this location. We illustrate the wiring diagram for where each of the components plug into on this CAN router in our manual, so I'd invite you to refer to that as well. In addition to that, not a Spyder Controls product, but something to be aware of where it's located, is the Magnum bridge module. It's located a black box here right beside the inverter, and that's kind of the brains of the communications to the Spyder network and how it interfaces with the Magnum inverter charger. So one additional component to be aware of that's new for 2018 is a new product that's installed in the TRC transfer switch. In this particular model, the transfer switch is on the passenger side of the motorhome. Typically it's on the driver's side where you'd find the transfer switch near your shore cord, and it's hard to see it here, So I'll just point out that on the transfer switch there'll be a little black dongle, if you will, sticking out of the transfer switch, and that device monitors all your AC power for your voltage, current, and frequency. We're going to finish up here on the roof of the motorhome, and each of the air conditioners for the 2018 models is equipped with Spyder Control's control module that's actually a Coleman product in the Coleman air conditioners. And so in each air conditioner there'll be a tin colored control box that's much like what you may be familiar with from past models, and each of those control boxes are networked together on the roof here to allow control of the air conditioners as part of the Spyder network as well.